Okay, first we are given that f of x is equal to this and f of y is equal to y. F of y can be rewritten as u of y minus u of y minus 1, and later after that we can shift it to the right by 1. For the sake of simplification, I tried this method and I wasn't able to get the answer, so I calculated by different method. So f of z is convolution expanded like this from minus infinity to infinity, which is given. So f of x of alpha is 1 in the range of 0 to 1, so we shift f of y z minus alpha, but z minus alpha exists only in the range 0 to 1. Now we find the limits of alpha. Substituting the limits of alpha, we find that it exists only in the region between maximum of 0 z minus 1, which is the lower range of alpha, and minimum of 1 z, which is the higher range of alpha and d alpha. Thus integrating we get this something like this, and 0 otherwise, yes. And this is the plot that we get. As we said earlier, we have to shift it to the right by 1, thus we get this. And now we proceed on to the geometric result. Here too, for the sake of simplicity, we shift to the left by this, and then later we shift to the right. So if z is less than alpha, it is the range which is less than this line, which comes here in this part. So this is nothing but the area of triangle, which can be calculated by z square by 2, and f of z is the differentiation of this, which 2z by 2 is z. Similarly, for 1 when z is between 1 to 2, what we are doing is taking the whole triangle and subtracting this and this. Actually, the shaded portion does not include, but I've taken the whole triangle and subtracted the area of these two triangles. This is why I get half z square, there's nothing here, minus 2 into the area of the other two square, 2 into half into z minus 1 square. Yes, simplifying we get something like this. In order to differentiate it for f of z, we get minus z plus 2. Plotting, we get f of z is equal to this. In order to shift to the right, we get this. Thanks.